Good evening, everybody in India, and good evening, good morning, everybody out there in North America, including Professor Chanda. I just give a brief introduction of Professor Chanda, and then I will give the floor to Professor Chanda to present his paper on convergence. I guess the paper is from got published in World Development. So let me just quickly introduce Professor Chanda. Professor Chanda is from Department of Economics, Louisiana State University. His research concentrates on long-term economic growth and productivity, regional economic growth, consumption and savings, and economic growth in India. He is the author of the book titled as The Rise of India. He also serves as a co-editor of Economic Inquiry and associate editor of Economic Modeling. He completed his PhD from Brown University and MA from Delhi School of Economics. I guess the paper which he is going to present today is published in World Development, and he is also owner, or I would say one of the significant author of one of the most cited papers, FDI, Financial Markets and Economic Growth. It's a very popular and most cited papers across the world in this particular area from Journal of Development Economics. Thank you again, Professor Chanda, for joining us and giving us some time. So Professor Chanda, the floor is for you. Thank you.
Thank you, Subaran, for that introduction, generous introduction. And thank you, Shivangi, also for helping arrange everything. So I'm glad to be virtually here, and I know that this is almost dinner time and you might be wanting to do something else. So I appreciate you all spending this time here and listening to my research. So this is a joint work with one of my recent PhD students. As you all know, Subaran was one of my, maybe not my first, my second, or maybe my first PhD student. And so this work is with Sujana Kabiraj. She's a recent PhD student and now at University of Wisconsin at Stevens Point. Let me share the slides. So I hope you all can see my screen. Yes. So this paper, Subaran asked me to present something on growth and convergence in India. So this was the one that I could quickly come up with. It's already been published. It was published last year, but I think given the period that it covers, the results are relevant, and I hope some of you will find this interesting and decide to pursue this kind of work further along. Okay, so the title says Shedding Light on Regional Growth and Convergence in India, and the use of shedding light is what figurative and literal out here, as I should discuss later on. Okay, so let me just give you some background about economic growth in India, especially regional economic growth. So as you all know, there's large differences across GDP per capita or well-being, or however you want to measure it in terms across states in India. So this is data from 2015-16, and if some of this data is from kind of ends at 2016 because that's when we finished writing the paper, and then it takes 4 years to get it published. So this is data from 2015-16, and from that time at least, GDP per capita of Gujarat was estimated to be 5 times that of Bihar. This is not surprising, and you'll probably know this this huge difference that's there. So if we look at some of the data that has come out pre-reform, post-economic reform, some of these official figures seem to indicate that things have gotten worse post-1991. So some recent papers that actually look at this in detail as Subramanian and Kumar, Deja and Chakrabarti. If you look at some of the differences, not just at states, but if you look at districts, so for example, I think this is an institute in Oxford University, which publishes the multidimensional poverty index for India. It looks at a number of things, including the head count ratio. For India as a whole, it stood at 12% in 2015-16, but again, there are huge differences. In Kottayam district in Kerala, this was at 0. In Adirajpur district in Madhya Pradesh, the poverty index was at 40%. So large differences across states, large differences across districts, something that you all are all familiar with it. So why are we doing this research? What is some of the things that got us interested? So first of all, the economy opened up in 1991. Now it's been 30 years since the economy's experienced medium to high growth rates. And when you all study economic growth, you'll study something like the Solow model. You study about convergence, you would have expected that, with 30 years or at least 25 years when we look at the data in this paper, you would have expected some sort of convergence to have kicked in. And yet some of the more influential papers do not show this, okay, or do not seem to pick this up. And so there are two kinds of questions one can ask. One is, which is what we do, which is to look at the data from a different perspective, or accept the way things are and ask, why is it that things are different? So this paper is looking at the first, which is kind of looking at a different set of data to see how true this is, and whether things have indeed diverged as much as some of the statistics suggest. Okay, and again, we know that India is definitely better than many other developing countries, but still the quality of the data is not very reliable. We know that there's a very large informal sector in India. Statistical infrastructure is not as good as that you see in developed economies. There's concerns about whether, when you look at data for GDP, whether you're picking up, adjusting for price differences adequately across regions. And once you leave states and go to districts, then the data is practically non-existent. So I should again qualify that, there's a lot of household data, which needs to come from the national sample surveys and other household surveys. Of course, NSS itself has not released data recently. And that again tells you a little bit about the problems, not just about the statistical infrastructure, but about the politics of statistics that you see in many countries, including India. So again, we know very little. So at the district level, the challenges become greater. And furthermore, when we look at rural-urban differences, again, when you study economic growth, you talk a lot about rural-urban migration and all these dual models of development, and yet we seem to know very little about the actual data that's about what's happening. So these are some of the broad, just suggest some of the view out here. Sorry. So this is some of the broad themes that has motivated this research. So what do we do? Our work is very different in the sense that we don't actually use gross domestic product data. We don't use household survey data. Instead, what we're doing in this paper is we're looking at satellite data. So we use satellite nighttime lights data, and I'll explain this in more detail in subsequent slides. We look at 520 districts, and this is partly because we're looking at census 1991 the 1991 district map. And we explore the spatial distribution of economic in India between 1996 and 2010. Why exactly these 2 years? I'll come to that also in subsequent slides. And our very basic question, straightforward question is, we're going to look on convergence regressions. Okay, just like you might do with GDP per capita, what we are doing with satellite nighttime lights. We're going to ask whether poorer districts are catching up with the richer ones. Is there any evidence of absolute or conditional convergence? In the case of conditional convergence, are there certain initial conditions that seem to matter? What about heterogeneity by states? Do we see things different for large states versus small states, poor states versus rich states? We develop a method of using this nighttime lights to distinguish between what are rural and urban areas within districts. And so we can ask further now, is most of the dynamics happening in rural or urban areas? Are rural areas falling further behind, or are they catching up faster? What's happening in urban areas? And at the very end, depending on how much time we have a very brief section looking at some of the large-scale poverty reduction and infrastructure programs that have been implemented during this time period, or at least that overlap during this time period. And the last one I should say is, it's sort of a very preliminary exercise. This is not, there's no clear identification or anything out here, so it should be taken as such. All right, so before I'll have a time to go through everything in detail, but before you start getting bored, let me just give you an overview of what are the results that we find. And so compared to the vast majority of the literature, our work is actually, our findings are much more optimistic. Okay, so we do find evidence of absolute convergence. So in other words, when you run a convergence regression, you don't need any controls beyond initial GDP, in this case, initial lights, to show that there has been absolute convergence. There are sub-period variations. So we have, most of our work is for this 15-year time period, 96 to 2010. And there are periods where you don't see convergence, and there are periods where you see convergence. One of the surprising results that we found is that not only has there been convergence, when you look at conditional convergence or you look at initial conditions, you actually find that regions that were disadvantaged due to poor natural geography have grown faster. So I'll go into this in a little bit more detail when I get to that table. Some initial conditions matter, and those are here, things that might conform to our priors. So access to infrastructure matters, literacy rates matter for rural growth, higher education seems to matter for urban growth. And the paper itself has 12 tables, then there are 4 or 5 tables in the appendix. So no matter how we slice and dice the states, how we construct the data, these results seem to hold. And one of them, as I said, our results are much more optimistic. One of the sort of constant themes through most of the tables and the results is that a lot of this is actually due to faster rural growth. Okay, so that's, positive result, if you like, positive not in the economic sense, but positive more in the literal sense. So let me give you a little bit of background on where the literature has been so far in terms of looking at convergence and divergence in economic growth. So if we look at official statistics between 1996 to 2016, the Indian economy has grown at an average of 7.2%. That's real GDP per capita growth. And a number of studies have been published over the past couple of decades, looking at various aspects of regional heterogeneity. And some of the well-known research here is Ghate and Wright, Kumar and Subramanian, Chakravarti and Dehejia, and most of them, all these studies look at state-level divergence and convergence, and define that they did not find any evidence of convergence. There are some studies that look at district-level data as well, and perhaps the one that's closest to us is the one by Das, Ghate, and Robertson in 2015. And they do find some evidence of conditional convergence for districts. So that's closest to our paper, except that they look at a very short period, which is 7 years. And they use some proprietary district domestic product data that I personally have a lot of reservations about, not just about it being proprietary, that's fine, data costs money to create, but also the manner in which that data has been created. And so in comparison to that, we are using a data that's sort of open to everybody to use. And of course, our data itself is there on the World Development website and can be easily downloaded. For a longer time period, we can look at rural and urban areas, which is something that it's very, official district level data is not something that you can use. All right, so as I said, we are going to be using nightlight data. And the idea is that nightlight data is a proxy for economic activity. So why don't I go to this slide first and then I'll come back to the other slide. So this has been an area of, this data has become very popular going back to a couple of studies. One, the most notable one is by Henderson, Storegard, and Weil in AER 2013. And they were the first to introduce nightlight data into understanding economic activity and growth, and they were introduced as a way to improve GDP measures. It's a very widely cited piece of research, and after that, there's been a lot of other work. The World Bank has become very active in using nightlight data for not just mapping urban agglomerations, but also just doing studies of convergence, economic activity. They've used it to study conflict. They've used it to study things like demonetization. Pinkovsky and Salah Martin have some research showing that nighttime light data is a very good proxy for GDP, and they use it to question some of the Penn World Tables data that's been used for a long period of time. Leisman and Seidel, 2017 European Economic Review paper that used nightlight data to predict state-level GDP and income inequality for 200 plus countries. If you're really interested in nightlight data and how it might be used, I think a very nice paper that goes into some of the recent developments and some of the problems, pros and cons, is a paper by Gibson in Journal of Development Economics in 2021. Right, so let me tell you a little bit about the nightlight data. So basically, the data that I'm going to use is what I would call the vintage version, because right now there is a newer satellite out there that's much better than the one that we've sourced data for. But basically, these are weather satellites that are that have been launched by the United States, and they're constantly looking for cloud cover. And part of what they do is they also, because they need cloud cover and they have to extract man-made, to look at the extent of cloud cover, they have to remove man-made lights from the pictures that they are taking, relaying back to National Weather Service or wherever. And so they release the data on man-made lights. And basically, these satellites are orbiting around the Earth all the time. And between 8:30 and 10 p.m., they take pictures of every grid on the planet. It's about a 30 arcsecond grid, which is about almost a kilometer by kilometer resolution of man-made lights between 8:30 and 10 p.m. And this do it daily. They were doing it daily with this satellite. And then this man-made nighttime light is converted into a unitless measure. This is basically using a hexadecimal system, and the extent of light intensity ranges from a scale of 0, which is basically no light, to 63, which is the largest amount of light. The way these sensors operate, they are top coded, so they may not give a very good idea of night lights if you are trying to compare Delhi to Mumbai to Tokyo to Los Angeles. You might just see the same value. Okay, so that is a problem with these measures, and I'll get back to that once in one of the later slides. The nightlight data, it's already been used by other researchers as a proxy for economic activity in India. Chakravarti and Deheja use it to look at states, for a dozen large states. Gibson et al. Have a paper, I think also in World Development, which basically they use it to distinguish between rural areas, small town, and big cities for NSS regions. And a large, there's a stream of applied micro papers, which is looking at village level, district level questions, district level observations to answer certain questions about politics, provision of public goods, economic activity. And they are all using the nightlight data as some sort of proxy for economic activity at that level. Okay, so one of the nice things about nightlight data, as I said, it's 1 kilometer by 1 kilometer. So you don't have to, if you know some geographical information systems, you can easily use a shapefile. You can use this to create nighttime light data at the village or the district, the town, the city that you want to look at. But there are limitations. It's everything is not just great about nighttime light data. One, as I said, it's top coded, and that's a problem, especially if you want to look at urban versus rural growth, and if you want to compare Delhi versus some rural areas in Haryana. Sonipat is probably not as rural anymore. This is going to be a problem, okay? Because it's going to naturally show that assuming that there are the villages around Sonipat, the electricity has increased there, nightlight activity has increased, but Delhi, it's not going to show any growth. So automatically there will be this bias towards convergence. So it's something I'll talk about, and I'll discuss how we deal with it in this paper. The other thing about nightlight data is it's a proxy. Okay, so you can always ask, well, so what exactly is this? Is it consumption? Is it investment? What is it telling us about GDP? So beyond saying that it's some proxy of gross domestic product, it's hard to know exactly what is it supposed to measure. So it's a correlation, and papers that go into this have very little to add beyond saying that it's some proxy of economic activity. There are technological issues with this. So for example, if you think about Delhi, which is a large, well-lit urban area, so the light kind of glows, and it glows into regions that are around Delhi. And so there could be a small town, a small village where the light that the satellite is picking up is not Delhi's night, is not that town or village's light, but the light that's radiating out from Delhi. So that's called the overglow problem. There is something called an airglow problem, which is more satellite, something to do with the satellite itself. There are gas flares. If there is just a refinery in the middle of nowhere, it's going to show extremely high amounts of light, and that does not necessarily reflect economic activity there. The data is corrected for the last one. And finally, the satellites change over time. So we're looking at, in some of the results, I'm looking all the way from 1992 to 2013. That's 21 years. And it's not the same satellite. Satellites rotate in and out, and every time a new satellite goes in, there is some improvements or there's some calibration to the instruments, and that creates its own set of problems. Right, so the one that we use is a slight variation. And basically, so these satellites were there between 1992 to 2013 for this entire period of 21 years. And as I said, one of the problems is this stop coding. And to us, that was one of the biggest problems because, especially if you're studying convergence, if the most well-lit areas are top coded, then there's going to be a natural tendency towards convergence. So what we did was the NOAA, or the Earth Observation Group in the United States, which releases the data, for certain years, they did some adjustments to the satellite to ensure that it was not top coded. Now, this is not a data that's used regularly by most of the researchers, but it's there. And the reason most researchers don't use it very regularly is because this is on certain years. So if you want to create a panel, it'll be like the first year is 96, then for 2 years it's not there, then there is some data for another year, and then again for 3 years the data is not there. But we decided, since we are looking over a longer period of time, we decided to use this data. The nice thing is that the upper bound is no longer at 63. The upper bound, the brightest pixel on Earth, is now at 2,379. I think that's Las Vegas, if I remember correctly. And so it solves at least this bias towards convergence that you might get with the standard nightlight data. Okay, so just to give you an example, if I use the standard nightlight data that everybody has used, Delhi would show 0 growth because Delhi is top coded. 1991, it would be 63, and in 2016, 2010, it would be 63. This data does not show that kind of top coding. So we take this data and that's the reason why we look at 1996 to 2010, because 96 is the earliest year where you can get this non-top coded data of lights, and 2010 was the last year. So that's why we have this weird time period. I mean, it's still a very, it's 15 years, so it's like a short time period. And we have robustness results using the top coded data as well. So this is just a picture, map of India, which tells you where in the growth in night lights have been the most and where growth in night lights have been the least. So if you look at it and look at your favorite district or your hometown, and you can see where it stands. So you see that this is an area where this is Uttarakhand and Himachal and parts of Kashmir, where you see that nightlight growth has been the highest. Some places in West Rajasthan that you see that nightlight growth has been quite high. And then you see other areas that are scattered. If I'm not wrong, this is Jharkhand, and then there are some northeast states. And a number of questions can immediately pop up. If you look at the Uttarakhand, Himachal, Kashmir areas, those are areas we could say, well, those are mountainous, the snow, is it due to reflection? Okay, and that's certainly a concern. We tackle that in the paper. Is it possible that West Rajasthan is showing a lot of economic growth or captured by night lights, but it's not really economic growth, it's just electricity growth. Maybe the government did a good job of these historically poor places and just provided them with electricity. Okay, so that's, we'll talk about all that when I look at the results. And of course, you can see that in central India, MP is particularly notable for standing out in terms of very low night light. Now here you'll see, if you look at the index, you'll see that some of the states, districts, particularly in Madhya Pradesh, the values are negative. And I would suggest that you don't take the values literally, because one has to ask, well, what exactly does nightlight growth, how does it correspond to GDP growth? And again, there are satellite issues. So what's really important here is not the actual quantities themselves, but the variation. Okay, and again, since we're looking at districts within India, and we're not looking at an aggregate measure of growth, that's what's important here is the variation and not the actual number itself. So before I present the district level results, let me quickly just show you what this looks like versus state GDP. I'm introducing a new measure, so no one could say, well, this is just complete nonsense. I don't know whether this has anything to bear with real world data in terms of economic activity. So this is state level GDP and night lights and per cap, both of them, and normalized by population, the log state GDP and log night lights per capita. And you can see that this is for as many years that you could get this data, for as many states as you could have data from national accounts. You see that there is a positive, if somewhat nonlinear, relationship between the two. We ran some state level regressions to see whether the state level GDP per capita can be explained by score associated with night lights per capita, and you see a fairly strong correlation out here. The estimated coefficient is significant, it's about 24. So that gives you an idea of the elasticity. So for every 1% increase in night lights per capita, there's a 0.24% increase in state level GDP. So here we look at, so if you look at column 1, it's a very simple regression, no other controls. We have 191 state year observations. There are no other controls for state and year controls. Here we introduce, column 2, we introduce state and year controls. And not surprisingly, the size of the coefficient goes down. If I introduce square log lights just to allow for some nonlinearity, it turns out both lights and square log lights become insignificant, and that tells you that the two of them are highly correlated. So that's what you're seeing out here. And then going back to this problem of night lights, so there is another problem with night light data, which is, one is that it tends to be top coded, though we are not using the top coded version. But there is also it's also truncated at the bottom. So what happens when in areas that are not well lit, it's very dimly lit. The nightlight data rounds the lights down to 0. Now, if you compare, let's say I take a 1 kilometer by 1 kilometer grid and I see that the nightlight is 0, but if I look at the census records, I'll see that there is a town there or a village there. So obviously there is population there, there is economic activity there. So one way to indirectly address this issue is we created what we call unlit pixels, which is created a measure of areas in a state or a district. In this table, it's the state, where the pixels are at 0 value, and we look at their share relative to the total number of pixels. So pixel, by the way, is a 1 kilometer by 1 kilometer grid cell in this data. And we look at that share as a way to control. And this also handles issues like what I said about West Rajasthan, that maybe the areas just doesn't have electricity and now suddenly they have electricity. So they all light up. It doesn't necessarily mean economic activity has increased tremendously. So if that kind of things are contaminating the data, we use this unlit pixel share to control for that. Okay, and you can see that the elasticity is 0.24. By the way, this elasticity of 0.24 is very close to some of the estimates that Henderson, Storegard, and Weil find in their AER paper for lights and GDP per capita. All right, so going to the actual convergence estimates. So what I'll do in this paper is I'll first present some absolute convergence results, then I'll present some conditional convergence results, then I'll look at rural versus urban, and then I'll look at some of the policy, large infrastructure and policy programs that were introduced during this time period. So, the absolute convergence regression is very straightforward, what you might have seen in a paper by Barrow or Mankey-Romer and Weil. The growth of, so here remember we're looking at lights, growth of night light per capita of district I and state S between the years 2010 and 1996. We're looking at the average annual growth rate. So this is annualized data. And the only independent variable here is the initial night lights, log of night lights per capita in that district in 1996. Beta 1 measures the absolute convergence rate, and that's pretty much it. It's as straightforward as regressions go. And I'm going to first present some state level regressions, and then I'm going to give you the district level. So this is for 1996 to 2000. So the first column is actually GDP. It's not night lights. It has nothing to do with night lights, but it gives you a sense of the divergence that many of the earlier papers have picked up as far as state GDP per capita is concerned. So you can see that that's what column 1 is showing you, that there has been divergence, not convergence. When you use night light data, instead you start seeing convergence. Okay, you can see that sign flips. It's significant at 1%. And you might be concerned that no, maybe it's something to do with the nightlight data, and perhaps there is something to do with the nature of nightlight data. So in column 3, we remove the possibility that this is simply places that had no electricity are suddenly lighting up. We control for the 1996 unlit pixel share, and you can see that once you control for that, you do not see any convergence or divergence. So in that sense, the nightlight data, at least at the state level, is not exactly the same as what the GDP data is saying, but is picking up the same thing, which is that there is no convergence. There is no convergence at the state level, at least. Now, of course, this regression is only 31 states. So, you can take it for what it is. So actually, I've already discussed this. Okay, now, so the column 3 is what leads us to our next specification, which is what we call a modified absolute convergence regression, where in addition to the initial night lights, we have this unlit pixel share. Now, once we start looking at district level data, we also have state fixed effects. Okay, so that's the uppercase DS. Okay, and then we have the error terms. So this is the specification for district level regressions that I'm going to start discussing. All right, so this is our main table, if you like. So this is first looking at our first main table, absolute convergence, looking at nightlight data for 520 districts between 1996 and 2010. So the first column is the cleanest absolute convergence regression, no other controls, nothing, no fixed effects, no controls for unlit pixel share. And you can see that there's clear evidence of absolute convergence, 2% per year, which basically means it takes about 30 years to close half the gap between the richest districts and the poorest districts. Also, this 2% is very close to what Barrow and Salai Martin have found for states in the United States when they look at convergence over more than 100 years. This is very close to that number as well. Column 2, we add the control for the unlit pixel share because that's always a concern with nightlight data. It reduces the convergence coefficients a little bit, but it's still, you can definitely see that convergence is there. In column 3, we add state fixed effects to see whether that changes anything. It makes the coefficient actually be a little higher, but it's still hangs around at 2%. In column 4, instead of introducing state fixed effects, we use the state level nightlights per capita. Okay, so this is just another way to check whether we're getting anything else out of looking at districts. Okay, if districts are simply replicating what you see at the state level, then everything that we do in this paper is kind of redundant. We could have just looked at state level regressions and be done with it. But you can see that we have two interesting things out here. At the state level, there is a divergence, but within states, you see that poorer districts are catching up with the richer districts. Okay, so you still definitely see convergence there. And column 5 repeats the same exercise, but again looks at state GDP per capita and not state lights per capita. And again, you see the results are very similar to what is there in column 4. Okay, so the main takeaway from this table is there is absolute convergence when we look at growth in our night lights. This is not due to dimly lit areas suddenly getting lit due to electricity connections. This is not reflecting what's happening at the state level. Okay, so that's this table. Okay. We do a large number of robustness checks. I'm not going to go through all of them. Actually, I do have the table, but let me just quickly, since I only have 7 minutes left to discuss another set of results. But so let me just tell you what we go through. We look at the top coded lights instead of the non-top coded lights. That allows us to look at a longer time period, 21 years. We find the same kind of thing. We use some instruments for the initial lights in case you think the initial lights may not be a clean independent variable. We use some other data sources. We use a 2011 census definition of districts, since we right now are not using any control variable from any data source other than night lights. We find the same thing is there. We do some robust regressions. The results continue to hold. So I'm going to skip table 6. That's basically the bullet list of things that I just mentioned. Let me get to the conditional convergence results. So what is conditional convergence? Conditional convergence is basically suggesting that districts have their own steady states and each district is converging to its own steady state, or districts with similar, within this groups of districts that have similar steady states, poorer districts are catching up with richer districts. Technically, given that I've shown absolute convergence, which is a very powerful result, conditional convergence is of little importance. Okay, usually people will look at conditional convergence because they do not find absolute convergence. Okay, so I'm going to show you conditional convergence because I just want to see what other initial conditions might really matter. So here what we do is we control for geography variables, we look at initial demographic characteristics, we look at human capital infrastructure conditions, And of course, just like before, we have state fixed effects and we have the unlit pixel control measure. So let me quickly go to column 4, since I am running out of time. So in column 4, the first thing to see is that the initial lights per capita, again, the coefficient is remarkably stable. It's at minus 0.02.3. So that's basically 2.3 rate of convergence. Unlit pixel share, I've controlled for it. It has a positive effect, which basically suggests that areas that there might be an electricity argument there, that places that are very dimly lit grew faster compared to other areas, but doesn't affect the convergence result itself. Then we have a bunch of geography variables. And one of the interesting things here is that if you look at agricultural suitability, which is basically a measure of the quality of soil, how easy it is to grow crops, areas that have high agricultural suitability actually did poorly during this time period. Normally, when you look at explain economic activity across regions, this is a variable that's usually positive because agricultural areas are more productive, so you expect them to do better. But remember, this is convergence, so that this makes sense that places that were fertile, that were growing crops, probably doing well already, and areas that were not fertile, that were not necessarily had these advantages, have actually done better during this time period. And a good example of this is, I think, Bangalore and Hyderabad. Ruggedness, which is basically mountainous regions. This is especially given what we saw about Uttaranchal and Himachal Pradesh, and Kashmir, might be worried whether this is just picking up, our results are picking up mountainous regions. Yes, mountainous regions have done well, but it doesn't do anything to the conditional convergence results. If you look at education, you see that the literate initial literacy matters. We do also correct for electricity connections, because we don't want that to be driving all our results. It's important, but it does not affect the conditional convergence result. And access to roads also matters. But again, remember, these are economic variables. One can talk about whether they're endogenous, whether there is omitted variable bias, all sorts of things. So you have to keep that in mind while looking at this set of results. Okay, let me quickly talk about rural versus urban, because I think really short of time now. So what we do is, because we have nightlight data, and so we're not relying on government statistical publications, there is people who have used nightlight data for urban planning and for studying other kinds of questions like climate change and whatever else. They have figured out ways to distinguish between what is likely to be rural versus what is likely to be urban. So we use that methodology to divide up, not just look at districts, but look at what I would call the rural and urban portion of districts. Effectively, what that does is takes our number of observations from 520 to 943, if I'm not mistaken, because some areas still are completely rural or they're completely urban. And so if you look at the growth, the total national growth in nightlights over this time period, 81% of the growth happens in areas that were rural in 1996. That's not surprising because India is predominantly rural. Of this growth, 81% fraction of growth in light that comes from rural areas, 27% are areas that remained rural. Okay, so the increased nightlight, you see increases in nightlight activities, but based on the definitions of what's considered rural, it still remained rural. 36% were areas that absolutely had no electricity. So out of the 81, that 36% had no electricity or were unlit, or the satellite was not picking it up. And those areas were contributed to nightlight growth. So that's a good percentage, right? It's not something that's why it's always there in all these tables, because I want to make sure that that's not contaminating our results. And 20% is basically because an area that was rural, now they had enough lights to be classified as urban. And from this 81%, the remaining 19% is due to urban areas that were already lit, and they continue to see an increase in lights. A lot of the growth in night lights is due to rural areas that were close to urban areas. So you can see almost half of the growth in night lights comes from those areas. So benefited from being being close to an urban area. So I'm at 9:45, and instead of presenting more tables, I think this is a nice overview table to stop and take questions I have, and maybe then I can present some other tables depending on what the questions are. So, so let me stop speaking, and Subaran, let me give you back.
Okay, thank you for this excellent talk. I was so mesmerized that I could not keep the track of time. I was just listening to you.
Oh, thank you.
So fantastic talk, very interesting. So I will open the floor for questions. If you can raise your hand, so you can ask your questions. But being a moderator, I would like to take a liberty to ask Professor Chanda one question. That do you think that this recent this convergence which is happening amongst districts, there is a significant role of, let's say, the improvement of, let's say, the roads, because in India we always talk about potholes, roads, and so I was just thinking like this. Is there any particular role? Because I was.
So that takes me to this slide, which is I couldn't get to this. So we look at three major policies during this time period.
Okay.
One is the Golden Quadrilateral Project. One is the District Primary Education Program, which has now become the Service, what is this called, the Sarva Shiksha Abhiyan. And then there's the Pradhan Mantri Gram Sadak Yojana project. The last one is the Rural Roads Project. And so here is what we do find, I'll tell you without going into tables, is that we find that the Golden Quadrilateral Project actually helped accelerate this convergence. So districts that were close to the Golden Quadrilateral highways experienced faster growth. For the other two, we don't find anything. So I think specifically the Rural Roads Project, we don't find anything, which, there is a paper by, I think, Asher and Novosad, which actually also finds something similar when they go into a very deep investigation of the PMGSY project. They don't find anything. So we also don't find anything from that.
Thank you. So I have Karthik. So Karthik, please go ahead and ask your question. And if you can, go ahead, please.
Good evening, sir. I'm Karthik from Patna, Bihar, and it was a great lecture. And I'm sorry I don't have an economics background. I have recently joined in public policy. I have a technical background, engineering background. So there were a lot of things which I didn't understand, like the nighttime light data and everything. However, you explained it quite well. Sir, there was a point in beginning of the lecture that you mentioned that in the course of the research from 96 to 2010, there were a few indices or parameters that have gotten worse since 1991. So if you could mention those parameters that have not done well, and yes.
So what I was saying was that the gaps have gotten larger according to some of the official statistics. So it's not, for example, that Bihar has not grown. In fact, Bihar, as you know, has done reasonably well during this time period. I don't remember if it was one of the highest growth states, but it's done well. The point is that the gap between Gujarat and Bihar had increased. Okay. Yes. So that's what I was getting at. It was not, or even in 2015, this measure of poverty that I discussed, Kottayam in Kerala was at 0, and Alirajpur in Madhya Pradesh was at 40%. Okay, so the point was that there are these huge gaps, and state level measures usually indicate that the gaps have gotten worse. Okay.
Just a follow-up question, sir. Bihar has, since 2004 or 5, if I'm not wrong, Bihar has seen a double-digit growth every year, according to the State Economic Survey. However, still, as per your research and the data suggests that the growth on ground and the inequality is increasing and the growth on ground is not very visible. So
So there are two things I'll say here. Sorry, did you finish or did you have?
yes.
So I just want to go back to the map. So this is Bihar. I mean, here you can, so this ends at 2010. So anything after 2010 would not be picked up. But if you look at this, Bihar is not too shabby. Now one can go and say, well, in the ground, perhaps there's increases in inequality, even though the district as a whole might have done better. And the nightlight data, again, one point that we are picking up is that rural areas have actually done well. Okay, so all that I can say is that this is different from some of the other results that people have found.
So, Professor Devachit, please go ahead.
Yeah, I can't switch on my internet connection is very slow, so I can't switch on my
please
camera.
go ahead.
Yeah, so it was a very clear and nice talk, and it is a delight to hear. So what I'm trying to actually ask here, basically, it is not a question; it is basically some kind of observation. So first of all, it is a technical question. First of all, that in the standard growth regressions, what we do is basically a kind of that sufficient conditions like say distributional measures like coefficient of variation or something. So that has not been there. So is there any specific reason that we haven't taken that? So this
I have actually. Sorry. Yeah, okay. I have. Yeah. Go ahead. Finish your question.
Okay. Yeah. And the second part is specifically if particularly you were saying some of the hilly regions were growing very faster, specifically the rural areas in the hills. So is there any specific reason for that? So why it is why those regions are growing faster compared to some other regions? So so that will be much more interesting to know.
Right. So those are both excellent questions. Thank you. So the answer to the first one, I do have a table in the paper where we actually look at the standard deviation. We don't look at coefficient of variation, but we look at the standard deviation in night lights across districts, and we show that has gone down. Okay. And given that the mean has gone up, that means coefficient of variation will go down also. So that's there. I mean, as you can see, I couldn't present most of the tables. I didn't plan to present. The other one, that's a very good question. It's in many ways, yes, it's leaving it open-ended. Basically, what I'm saying is, it's not just the mountainous regions, it's the mountainous regions, the regions that do not have fertile soil. These are the regions that are actually remote, away from the coast. Especially in economic growth, we keep talking about how coastal areas have done better over the past 150 years or thousands of years. It's been a natural advantage. But the thing that the paper has picked up, and I don't have an explanation for it at best, that maybe some of the forces of convergence that you'd expect with high economic growth have been working. It's possible people have left there. It's possible economic activity has moved into those areas, and economic growth in the country as a whole has benefited these areas that have lagged behind, that historically have lagged behind. And so let me give you some interesting my perspective on this. Normally, when you're looking at paper of convergence, you expect to see convergence. Okay, and the question is then, why is it that you don't see convergence? Now, is it because there are bad policies that are hindering convergence? Is it because of problems with transportation or geography or something else that would normally the convergence result doesn't hold? So what I'm showing here is really sort of going back and saying, okay, we expect to see convergence, and we expect to see growth kind of benefiting other places that were behind, and you see that. Okay. And you see that repeatedly, not just in the per capita measures, but also in the bad geography measures. So it's not an answer as much as, it's not explaining, telling you why. I know, by the way, Uttaranchal has done very well as a state.
Yeah.
Right? So it's, at first I was worried, but then I looked deeper and it's not.
So let me go to Shubhashish. Shubhashish, can you ask your question, please? And if you can switch on your camera, that will be good.
I can ask my question, but I think I'd like to hear what Arjun Verma has to, our student Arjun has to say first.
Okay, so let me go to Arjun first, then I'll switch back to Shubhashish. Arjun, please ask your question.
Yes, I'm sorry I won't be able to switch on my camera. The internet in my area is very weak. Thank you, Professor Subhashish, for that opportunity. Great talk, Professor Chanda. My question is,
Thank you.
when we look at this particular map, this particular data that we have on screen, you have referred to the fact that rural areas and especially areas that are geographically very not really mobile, it's very difficult in terms of climatic conditions. Also, these areas really present difficulties, be it the coastal areas or hilly areas. Do you think that over time, because we are looking at 1996 to 2010,
Mhm.
use of, let's say, very basic things that we in urban areas take for granted, light bulbs or lighting for roads, have increased in such areas, and which has really resulted in the increase in growth in these particular areas?
It could be. We looked at this in a little bit more detail, and there's a table in the appendix where we compile data together on villages and electricity growth in villages during this area to make sure that that's not what's driving our results. It's possible. I mean, again, if you think about economic activity, diffusing across the country, you would expect these areas to have better roads, better electricity, a few more better opportunities than what they were in the past. So those, when we introduce variables like roads or growth in electricity connections, they don't challenge our results. They're there, but I don't remember it being particularly significant, particularly the growth in electricity. But yeah, I mean, I don't see why those things would not matter. I mean, it's hard to think of economic activity increasing without some of those things, right?
Yes, Professor.
Okay, Shubhashish.
Thank you.
Shubhashish, do you have a question?
Yes.
Yeah, go ahead.
This is more like a broad brush question. So as I was listening to your talk, which is a very nice talk, I was also thinking back to your, the work you had done on ancient statehood.
Oh, thank you.
And
Yes.
I was trying to sort of bring them together. So the message that I see here is that at the district level, so all that path dependent stuff seems to be happening at the state level,
Right.
but somehow, but it doesn't seem to be happening at the district level, right?
Right.
Where you see all this convergence happening. So that raises a question. So what exactly is going on? And ultimately you think of states as collections of districts, right? So how come you see this result at this disaggregated level, but at the aggregated level,
this is, it's not necessarily, they're in conflict. And for example, I mean, I don't know, I have not looked at those two, so I'm just speculating here. I can just use your excuse as a broad brush, which is that, it could be that some of this is happening in areas which have had more historical states. And so it's,
no, but it seems as if at the state level, you do see.
Right. So what I'm saying is within states, it's possible that, areas that have more historically developed historical states, which have deeper roots, those are areas that are the places where the districts have managed to catch up. Okay, whereas at other places they don't. I don't want to pitch my another paper, but I have this paper on subnational growth across the world, where we actually find some of that, which is that you find variations, divergence at the national level, but convergence within the subnational level.
And you were able to connect it to sort of history of statehood and stuff like that.
Well, I mean, I would say very indirectly connected, because we were looking. I mean, I won't say that.
No, and also just one related question. So in your conditional convergence model, do you? Because at the district level, you have colonial data and so on, right? Iyer and so on have some data.
Yeah, we didn't do all that. I mean, we didn't look at those. That's true.
Okay.
We didn't look at them. I mean, that's the honest answer. I have not looked at those. I mean, it'd be interesting. But I think, part of the problem is that those districts, when you go back and look at Iyer and Banerjee, you're down to 300, 400 districts, and they're defined based on 1951 census or something like that.
Mhm.
And so it can be done, but we just haven't. I think there's actually a paper by now that you mention it, this guy in Irvine, UC Irvine, Priyaranjan Jha. Look at his website. I think he has a recent paper on this, looking at colonial institutions and recent growth. So, and he is using nightlight data, I'm pretty sure.
Okay. Thanks for sharing that.
Okay, thank you. I still have 2 more questions, but I will not ask. I will not go ahead.
It's up to you. I can answer the question, or if you want to close the meeting.
No, that's fine. So in that case, let me ask the question raised by Chitrakalpa Sen, who is right outside. So on the road, so he is asking me to just read it for him. So I'm asking, can you, if the nightlight data is able to explain the rural-urban migration or reverse, or the reverse?
Again, I'll be because it's not tracking people, right? It's tracking lights, okay? So now, to be able to answer that question, you would need to look at areas where it's a little bit more complicated, because let's think about a place which has seen a lot of migration, okay, out migration. Let's say a rural area, you've seen a lot of out migration. If you've seen a lot of out migration from that place, it's possible that the remittances back to that place has increased economic activity there. Okay, so it's a little bit more complicated in terms of what we expect for night lights. It's not that you'd expect night lights to go down in that rural area. It's possible that night lights go up on a per capita basis, especially. Okay, so again, it's sort of taking the neoclassical marginal product relationship and applying that. If a lot of people leave a place, the marginal product of labor in that place should go up.
Okay, so I saw Muskan, you had some questions, so you raised your hand. If you can ask your question, and then I'll close the question session after giving the chance to Debajit again. So Muskan, your turn.
Yeah, so thank you. Okay, so continuing Subhash's question, which was at the aggregate level. So I observed that we can see conditional convergence, also absolute convergence. So my question was, what particular factor do you think could have led to this result mainly? Since absolute convergence is a great result, which we can see, and it's a really positive and optimistic thing for Indian states. So what particular factor would have contributed the most?
So it's very hard to answer that question. I would sort of say that if I had to give my paper an angle, I would say that it's basically economic growth has been good for the poor.
Okay.
Okay, so that sort of thing, that's what you'd normally expect. Okay, and usually you have to explain the opposite thing, which is why has it not been good for the poor? And so in this case, it's basically saying that, look, if you look at the nightlight data, things don't look as bad. But I should say that, most of the time we spend time thinking about why things have been bad for the poor. But if you look at some of the other research of Gibson et al. Paper that I cite in my paper, they look at NSSO regions and they look at poverty, and they show that actually during this period of economic growth, poverty has gone down, especially in mid-sized cities. Those mid-sized cities and towns have done quite well over this period. Okay. So it's not that I wouldn't say that my results are completely different from anything that everybody else has found. That's not actually true.
Okay, so thank you.
So Debajit, you wanted to ask one question?
Yeah. So again, one another technical question. So there is in this kind of growth regressions, there is a possibility of Galton's fallacy, regression towards mean. So is there and the coefficient we are getting, the beta 1 we are getting, is close to 2%. So there is a famous paper by Professor Danny Ko, And it says that in case of this kind of regression, if we get a value close to 2%, it may be due to the Galton's fallacy itself. So is there a possibility, or have you tried to look at that aspect?
I have not. So something that I can look into. I'm vaguely familiar with the Kudani-Kwa paper that you're talking about.
Yeah, 1993 paper.
Yeah, 93 club, the one that set the club convergence literature.
Right, and there is another paper by Milton Friedman as well, almost in the similar time.
My only counter thing is that on average, on aggregate, we see economic growth, right? So given that on aggregate, we see economic growth, that given that we are seeing that rural areas are growing faster relative to urban areas, I don't think this is Galton's fallacy. Because it's not like the entire country is staying at a mean level.
Right.
Is it?
Okay, since we do not have any further questions, and I'm again thankful to Professor Chanda that based on my request, you gave us the talk, and it was fantastic to have you, and it will be great, like whenever you visit India, if you can visit our campus, and we can have an interaction face-to-face with the faculty as well as with the students. That will be of immense pleasure to us. Again, thank you for your time, and thanks for the talk. So thank you from my side.
Thank you again for inviting me, and I'm grateful again so many of you showed up for this talk and all the interesting questions. And yeah, I definitely, I hope that we can meet in person in the not too distant future.
Okay. So thank you, and good night for people in India, and have a good day, sir.